Next, I would like to talk about transamination. In the previous example, I showed you a way that we could create cis-alkenes. Now here's a way that we can create transalkenes. Now the way this works is that we use sodium and ammonia and iron 3 chloride, and what happens is that the sodium will add to the triple bond in the same way as if you go back and take a look at the alkoxide reactions back in test 3. The sodium has an extra electron on the outside that can add to a bond, and in this case it adds to the C, and we end up getting 2 electrons on this carbon here. Now a negative charge comes in and takes the hydrogen, and then we have another atom of sodium donating another electron to this radical here, so we have a negative charge on this C here. Now the important part of this particular process is that we end up with this negative charge, and for some reason, and I don't think anybody really knows why, it wants to be trans. So now this negative charge with these 2 electrons is in a trans situation with this hydrogen, and it will now allow for the negative charge to react with a hydrogen from an ammonia, and we end up with our transalkene. This is not a mechanism you have to know. This is one that you might be able to get a bonus point for if you see it on the test. The reaction itself is called stereoselective because it selects a trans stereochemistry over a cis stereochemistry.